So as we know, presently we are studying kinetic energy. So, as we discussed in the last class, kinetic energy means the energy possessed by any kind of body by virtue of its what, everybody?
Motion.
Motion. So, kinetic energy, if you have been taken, so due to the motion of the body, that is what we used to say, a virtue of its motion, we used to call it as a kinetic energy. As I told you, the kinetic energy formula is equals to half into m into v square. And last class, as we discussed, the suppose a stone is dropped towards the ground from a 20 meters, and then it is some other height, and then it is some other height. So that is what then, like you can take in a sand area or a wet sand, so that the depression created by it is keep on increases when the height above from the ground is increasing. Means when you take the same body like different heights, so that the height above from the ground is keep on increasing, then the depression created by it is also increases. That is what we have been proved in the last class. So depression created by the body is directly proportional to height above from the ground which it has been dropped. Am I right, all of you? Please respond. Everybody?
Yes, sir.
After class we have done or not? Everyone. So that is what. So let us comes to the examples of kinetic energy. So if you take many examples, we can take in our surroundings. So for example, a flowing water. So if you take the flowing water, so definitely they will possess the kinetic energy. If you fire a bullet, that is what a firing bullet. So that is also will possess kinetic energy. If suppose a moving ball, you can say that a moving ball breaks the stems, breaks a stump. So that is also possess kinetic energy. A windmills. So windmills, the air will rotate the blades of a windmill. That is also possess kinetic energy. So like this, different examples we can take. A moving car is also an example of kinetic energy. So all the moving objects, definitely they will possess the energy. That is what we used to call it as a kinetic energy. So by virtue of its motion, whatever it is possible. So every object, moving object, definitely it will possess the energy. That is the energy we used to call it as a kinetic energy. So now, in today's class, we are going to make a formula for kinetic energy and as well as work energy theorem, and then we'll solve the questions. And remember, kinetic energy will be the most important concept even in again in class 11th also. So the questions what we will solve is even will go for a up to a basic level of class 11th. So that is why, so have a glance and start thinking. If there is no individual thinking, always you cannot follow the teachers. So you must have something, okay. So personal thinking is what is self-answering is very, very important. What my method is like my teaching. So concept alone I can make you to build up. After that solving, you should start thinking what is the ways to solve the question more better we should work it. Okay. So kinetic energy. So kinetic energy, see the derivation also I'm saying you. So professionally you have to solve it. It's not that namesake you can. So everything you have to do it very professionalism, like we can say. So I'm considering for kinetic energy a body of mass m and whose initial velocity is 0. Means body is said to be in what? Anybody?
Yes.
Rest. Very good. Okay, Sam, no problem. You can listen. So I'm considering, let us consider a body of mass M. Let us consider a body of mass M, initially at rest. So initially at rest means, what is that initial velocity, everybody? What is
Zero.
initial velocity? Zero. So I will take it as a 0. Have you taken? You might be remember, before when I taught kinetic energy derivation, I have taught you body is having some velocity V and it is brought to the rest. Am I right, everyone? You remember, all of you? Check your derivations. The derivation what we have done, or the derivation what you have learned in the school, the body is already having some velocity V and it has been brought to the rest. Am I right? Verified. Okay. So, but now I am taking a body whose mass is m and whose initial velocity is at like 0, means a body is at rest. Do you understand, Amma? No. So if the body is at rest, if you want to make it move and I want to change the velocity to v, then you need to apply something. What you need to apply? Anybody? If you want to
Energy.
change the velocity, energy will apply, Amari. Generally,
Force.
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 That is what I'm saying. So a force F is applied, a force F is applied on the body. A force F is applied on the body so that the body velocity changes to where? The body velocity, it gains or not? Velocity increases or decreases? It is force is applied so that velocity increases or decreases?
Increase.
Increases. So let me take that velocity is v after traveling a distance. After traveling a distance. What is the distance we used to represent? Everybody. Yes, please. After traveling a distance. Yes. Clear, all of you? Yes. So now is velocity is increasing from 0 to v, so that acceleration produced in the body, what we can take? Positive or negative? All of you. Let A be
Positive.
let A be the acceleration produced in the body. Acceleration produced in the body. So this is what is the terms I have taken. Initial velocity is 0, force is applied F, velocity changes to V, distance traveled by the body is S, and the acceleration of the body is A. Now, according to this, I will draw the diagram. So if you have noticed it, so there is a horizontal surface as a ground. So I will take it. So now object is mass M, whose initial velocity is u, so which is at initially at a point. So certain force is applied, a push or pull, doesn't matter. So after traveling a certain distance, this object came into the position B. So that is what is the distance traveled by the body, I will consider as a S. And by that time, what is the velocity of the body? Everybody? What is the velocity of the body? V.
V.
Clear, all of you? That is. Now, as we observe this figure, you see that we are observing the body moving from where to where? Everybody. Speak, guys. Moving from where to where? Moving from A to B.
8.
Yeah. A to B. Using Newton's second law. Using Newton's second law of motion. Second law of motion. So what is Newton's second law? Everybody?
Force equal to M.
Yes.
F is equal to
F is equals to mass into acceleration. So this is what is equation 1. Let me consider that is the equation 1. Any doubt you can ask me. All of you. So listen everybody, in our NCERT book and as well as the method which I taught you before and the method which you learn, everybody, wherever you go, the people will take a body is already having some velocity and has been brought to rest after a distance, traveling a distance of s. That is the method you have been derived. Am I right? Everybody check your kinetic energy derivation which I taught you long back, or else you might be studied from the school. You can learn, you can see that. Initial velocity is v and final velocity of the body is 0. Am I right? Anybody? Abhirami, you can verify it. So now, let us take now. So from the third equation of motion, you can see all the terms I am not at all talking about the time. So if there is no time parameter, so which equation I will take, everybody? All of you? Yeah. From third equation of motion, listen, the method which I am taking you now, this is not that something unique. It is a well-known method for everybody, but this is very less people only knows. Everybody will follow the common approach. Even you take the Google, you take anybody's, they will take initial velocity is v and final velocity is 0. So body brought to rest after traveling certain distance. But you need to know the something differently. That's the reason we are taking. Of course, that is also will solve. So what is the third equation of motion, Kishore? What is the third equation of motion?
V square minus V square is equal to 2as.
Very good. So V square, anybody having doubt, you can ask me, Amma. V square is equals to U square plus 2as. Very good. So as we all know, initial velocity is what, Kishore? In our, according to our consideration, initial velocity is what? 0.
0.
So V square is equals to, initial velocity is 0, which is equals to 2as. Now, from that, can you tell me, Kishore, distance travel is equals to how much? Distance travel is equals to V square by 2a. Is it okay, guys? Will you all agree with me? So let me take this is equation number 2. Okay, wow. Yes, please. All of you?
Yes, sir.
Yes. So now, a force F is applied. A force F is applied on the body, and it has moved a displacement S. Displacement. So can you tell me what is the work done on moving a body? What is the work done on moving a body? Work done is equals to work done on moving body. On moving body is equals to how much, everybody? Work done, raw. Work done is equal to what? Force into displacement. Okay, wow. All of you clear? Yes, please. So now,
Yes, sir.
first equation. What is our first equation? Verify. F is equals to what?
M into A.
M into A. Second equation, displacement is equals to what?
V square by 2A.
V square by 2A. You have to say that. That is what? So M into A into S is equals to what, everybody?
V square
V
by
square
2A.
by 2A. Clear? All of you? Now, something will get cancelled. What will get cancelled?
A.
A will get cancelled. So this by 2, I will bring it first. So if I will bring it first, it will become what? 1 by 2. Okay. M into V square, which is equals to work done. Is it okay, guys? All of you? Yes?
Sir, kinetic energy.
Yes. Wait. That we should write. So this work done will appear as in the form of what? Everybody? Will appear in the form of what? Will appear
Energy.
as
Kinetic
the
energy.
kinetic energy of the body. Thus, Mr. Gokul, are you there in the meeting? Kinetic energy equals to half into m into v square. So R I can say EK. So subscript EK. EK is equals to half into m into v square. All of it clear? Anybody having any doubt? You can ask. Clear, everybody? So this is what it is. So I will say kinetic energy is equals to half into mass of the body into velocity of the body square of velocity of the body. Clear, everyone?
Yes, sir.
Yeah. Next, from the formula, forget about 1 by 2, it is a constant. So kinetic energy is directly proportional to mass, and kinetic energy is also directly proportional to square of velocity. Square of velocity. So these are the factors which will influence the kinetic energy, means it may increase or it may decrease as the kinetic energy. This is what is everything. Please make sure anything doubt till here you can ask. Do it fast.
So can you please up this screen?
Yeah, I'll come from the first. You can slowly write it and you can solve it. Any one of you having anywhere doubt, you can ask me, I'll explain it. Agalya, clear? Kavya?
Yes, sir.
Yeah. In the case of kinetic energy, Mr. Kishore, in the case of kinetic energy, which is equals to work done by the body. Do you understand the way?
Yes, sir.
Yeah. The amount of work done to change the velocity from 0 to v, which is equals to kinetic energy possessed by the body. Do you understand, Mr. Kishore?
Yes, sir.
Yeah. Hasani Sudhakar understood?
Yes, sir.
Mr. Gokul solving now. Simplicity. Make it quick, everybody. Completed?
So please wait.
No. You solve, no problem. Mr. Sanjay, understand? Sam? Lingesh?
So can you please up this screen?
Yeah. Okay.
So no, sir, from third equation motion.
Oh.
Yes.
Do it fast, Sama. Every moving object, it will possess the energy. That is what is the kinetic energy. That's all. A moving object, whatever the moving object, if it is possessing the energy, definitely every moving object will possess the energy. That moving energy, that energy possessed during the motion is called as a kinetic energy. Okay.
Okay, sir.
Yes, sir.
Completed everybody? Now, if you take H on the book, you will be having H on the book, or you take your NCERT book. So you can verify it. It has been solved in a different way. So that is what they will take it as a, basically they'll take it, they'll consider as a initial velocity is v and final velocity is 0. So in such a way they'll solve, but that is also not necessary to worry. The same answer will come. So by that time, to bring the body to rest, definitely we have to do some work done. Am I right or wrong, everybody? Suppose the body is traveling with 100 km/h. If you want to bring it to rest, definitely you need to do the work or not. You have to do some energy or not. All of you? Yes, please. So that energy, which is equals to the kinetic energy. The energy which is, you can check it. So I will show you that. You are all having H on the book. Those who do not have also soft copy will be having. So here what is happening? The same formula for kinetic energy. So you all can notice it here. So this is a different thing. This is what is your NCERT also. So the kinetic energy of a moving body is measured by the amount of work it can do before coming to rest. So means a body is already having some velocity v, and finally after reaching to the point B, it will comes to the what? Everybody? It will comes to the what, everyone? Rest. Means final velocity is what? What is the final velocity, guys?
0.
0. So that is the reason. Have you checked it here, Mr. Nivedan? Force is applying opposite direction. Means what? It is a what? Acceleration or retardation? Velocity is in forward direction. Motion. Displacement is in forward direction, but applied force is in backward direction. So it is acceleration or retardation? Everybody. Yes, please. Acceleration or retardation? That is what I am asking.
Retarded.
Retardation. So acceleration is what? Minus or plus?
Minus.
Minus. The
Minus.
velocity gradually it will decreases and it will finally comes to rest. After reaching to the point B, the body comes to rest. Means it will become 0 velocity. Velocity capital V is 0 of the body when it will traveling after certain distance. Then again same work done is equals to F into S. That is what, which is equals to the kinetic energy. So now again using third equation of motion. So the only change is instead of here A, they will get minus A because it is decreasing axle velocity. Velocity is decreasing. So acceleration is negative or positive? Velocity decreasing means everybody.
Negative.
Negative. So from that you will get V square is equals to 2AS. But here final velocity is 0. Understanding? And initial velocity is V. Initial velocity is V. Final velocity is 0. So the third equation of motion, V square is equals to U square plus 2AS. So final velocity is 0. Initial velocity is V square plus 2 into minus A into S. So this minus 2AS will come this side. So V square is equals to 2AS. Okay, guys, everybody? You understand? Mari? So this is what different methods you can solve. And again, from here, Newton's second law. So it is very confusing method also. So we have to replace from the Newton's second law, F is equals to ma, A is equals to F by m. So then this A they are bringing and substituting here in place of where? Acceleration. So we are getting V square is equals to 2 into F into m divided F by m into S. So then they are making F into S, they are keeping one side, M will come this side. What will happen? Multiplication. So M into V square, 2 is in multiplication, will come this side, it will become division. So that's what it is. So we all know F into S is equals to what, everybody? F into S is equals to what, Ra? Work done. Or which is equals to what? Kinetic energy. Understand, Amma? Yes, please.
Yes, sir.
So that is what. So kinetic energy equals to half mv square. That is what they are making. So same derivation, but we are considering initial velocity is 0, and after traveling certain distance, the final velocity is v. So what is the difference is only the let. So if you write a let, nobody can stop us. So our choice it is. That's the reason both you need to have it. Whatever you are convenient, you can go through that. So this question has to arise from your mind. Sir, why can't you take initial velocity 0 and final velocity is v? Because as you already studied this one long back, initial velocity is v, and after traveling certain distance, body is comes to rest. We have derived in our classworks. Verify it, either you have done or not. I want to know, everybody. Are you clear, everyone? All of you? But now in a Chand book, the factors what I said, important conclusions. This is what it is. So both important conclusions, directly proportional to mass of the body, directly proportional to square of the velocity of the body. That is what a kinetic energy is directly proportional to square of velocity, directly proportional to mass of the body. So please note it, everyone. Are you clear, everybody? Yes, please. Any doubt, anybody can ask. Okay, guys. Yes, all of you?
Yes, sir.
Yes.
Yes.
Please do it.
Sir.
So this is what is about the kinetic energy. So very important approach. Definitely we'll be having even in future. So you can take it and do it. So now your NCRT, you can check it. So NCRT, sir, what is the approach? So you can verify it. So NCRT also, it will be, if my guess is true, it will be followed from initial velocity is v and final velocity is 0. So let us just check it. You are having books correct. You can go through that. So I hope you all understand, everybody. Clear, Amma? Anything doubt, please let me know. Understood our derivation. But exam, what is very important? The let. Let what you are considering is a most important thing. Are you clear, everybody? So if you are not considering let, and simply, sir, I will write kinetic energy equals to half mv square. Sir, mark is not given. That is not acceptable. So again, I'm saying you. So we have to be very, very careful. What is our observation? What is our, like we can take, what is my expectations? So you can take it. So your choice. And by the time nobody can say any objections. So your view, what is your aspects, you can proceed it. Now book you can verify it. So we'll go through that. So kinetic energy derivation. Yeah. I think here it will comes. So yeah, they are also see that. Book they are considering initial velocity is 0. So let us now express the kinetic energy of an object in the form of an equation. Consider an object of mass m moving with a uniform velocity u. Let it now be displaced through a distance s when a constant force acting on it, and the direction of its displacement. From the work done, you can see that, yeah, and it will causes velocity. The velocity changes from u to v. So let the acceleration is produced by is a. So now all of you notice it here. They're taking f is equals to a, verify it. Oh, they're taking, if the object is starting from its stationary position, they are considering. But this approach is completely different. Have you noticed it? Initially, they never mentioned anywhere. It is starting from the rest. Have you taken? Simply they have taken at the middle. They have taken initial velocity 0. Do you understand, Mari? If the object is starting from its stationary position, but here what they mentioned, let means our assumption. What is your assumption? But here what they are saying, you see that moving with a uniform velocity u. Do you understand, everybody? Are you clear? So the approach is different. So the approach, whatever you can take it, you will note it is. Then later you have to be considered. But here how the book they are solving, acceleration formula they are using. So the same equation you can see. So this is a third approach from the NCRT. So NCRT, what they are trying to do it, guys, initially, that is also I will explain it, because you are not supposed to face any difficulties in the exam. So what they are doing, guys, Initial velocity 0, later they are considering. So first, same approach it is. You can see. So they are considering let initial velocity of the body is u, final velocity of the body is v, body travel a distance of s. Okay, everybody? Clear? And acceleration of a body is a. Now, what is from the Newton's second law? F is equals to ma, equation 1. Next, second one. What is that, everybody? F is equals to ma. Now, second equation. From the third equation of motion, v square is equals to u square plus 2as. Now, from that, I will say, everybody, so s is equals to u square will come this side, it will become, let me write 2as. 2as is equals to v square minus u square. So, from that, s is equals to what? V square minus u square divided by 2a. Am I right, guys? Please respond, everybody. Are you understanding? All of you?
Yes.
Yes. So now what they are doing, work done is equals to, we all knows that energy possessed by a body to change the velocity, from u to v after traveling a distance, yes, to change the velocity from u to v, the work done is equals to energy possessed by a body, which is equals to what? Force into, speak loudly, force into displacement.
Displacement.
So force is equals to mass into acceleration into displacement is equals to what? V square minus u square divided by 2a. Okay, va? Ellame understood, ma? Yes. So acceleration get cancelled. So we'll get the kinetic energy is equals to m into, so half will come front, m into v square minus u square. Now they are considering if the body is starting from rest. If a body is starting from rest, starting from rest. So what is the initial velocity? Everybody? 0. So that what will happen? So kinetic energy possessed by the body is equals to half into m into v square minus 0. So which is equals to what is the formula? Half m v square. So this is the approach of NCERT. So now the same approach here I will take. If the final velocity is 0, body came to rest, final velocity is 0 and initial velocity is v. Then what will happen, everybody? Formula. Make it, everyone. Ek is equals to half into m into final velocity is 0
Right.
minus initial velocity u equals to v. So that v square. So you can notice it here. By the time acceleration also 0. Sorry, minus. So here what will happen? Minus 2a will come. Minus 2a. Do you understand, all of you? So by the time what will happen here? S is equals to minus of, so minus of will come, which is equals to minus v square plus u square, which is equals to u square minus v square. Okay, Mari? Do you understand, everybody?
Yes, sir.
Yes. Because acceleration is decreasing, velocity decreasing. So by the time what will happen? So acceleration is negative. Is it right or wrong, everybody? Yes, please. So v square is equals to u square minus 2as will come. Why? Acceleration is negative, decreasing acceleration. So our assumption is very important. What approach you are taking is purely based upon your choice. Nobody can force it. Nobody can do it. You are convenient, you can do it. So which is convenient for you, you can solve it now. So according to NCERT also we are studying. According to your methods, everything I am teaching you. So whatever you are convenient, you can proceed it. You don't have any problem. Nobody can say any objection. So now NCERT, what they are doing? Middle they are taking, you see that. If the object is starting from rest, initially they have not considered. Then the initial velocity is 0. So initial velocity 0 means what is the work done? Work done is equals to kinetic energy. That is what? Half m v square. Understand, Nivedan? Clear?
Yes, sir.
That is all. So which is convenient for you is actually is very important. So please proceed. Okay, and make it. Any doubt you can ask me. Otherwise you can proceed. Okay, guys. Meeting is going to end. Join back so that we'll go with the next concept. I hope everybody is understand this. So anybody having any doubt, you can ask. Sam, understand, Sam?
Yes, sir.
Yeah.